everybody. In this video, we're going to be talking about how to use Hamilton's method of apportionment. So take 3 deep breaths and let's make this math easy. Okay, so before we talk about Hamilton's method of apportionment, I first want to talk about what apportionment means in general. So one of the applications of apportionment is dividing representatives between states. So in the United States, we have a certain number of representatives that are in the House of Representatives. And the question is how do we divide these representatives fairly between the different states? Because some states have more people in them than others do. And so this is kind of the main idea of apportionment, but it can also be applied to lots of other situations. Like you could use it to decide how many people you're going to schedule at a restaurant, depending on how many customers you have during each shift. And there's lots of other applications like that. So Hamilton's method of apportionment was invented by Alexander Hamilton, who's one of the founding fathers of the United States. And his method of apportionment was the first method that we used in the United States to distribute the representatives fairly between all of the states. So I'm going to show you how his method works by using an example from Denmark. So Denmark is a pretty small country, and there's 5 different regions in Denmark. And according to what I found on the internet, these numbers represent the population of each region in Denmark. And because Denmark only has 5 regions, this is much easier than doing it for all 50 states in the United States. So the way that Hamilton's method works is you first figure out what the total population is of the entire country. So to find the total population of Denmark, I'm going to take the individual populations of each region and add them up together. So I'll have 1,867,948 plus 1,341,857 plus 591,740 plus 843,513 plus 1,228,362. And that tells me that the total population of Denmark is 5,873,420. And then you're going to find the standard divisor. So the way you find the standard divisor is you split up the total population into however many groups you have representatives for. So in this case, since we have 175 representatives, I'm going to take this total population and divide by 175. And what this standard divisor means is that each representative will represent about 33,562.4 people. Now, obviously, you can't represent a decimal of a person, and also the individual populations are not necessarily going to divide evenly into this standard divisor. But that's what the standard divisor represents. And so what we'll do next is we're going to calculate the standard quota, which we do by taking each individual population and dividing it by the standard divisor, because that will tell us approximately how many representatives should go to that region. So for the capital region, I'll do 1,867,948 and divide that by 33,562.4. And that gives me the decimal 55.6559. Then I'll do the same thing for the central region. So I have 1,341,857 divided by 33,562.4. And that gives me the decimal 39.9809. And then I'll do this for the other 3 regions as well. And once I do all of those calculations, I end up with all of these numbers. Now, what these numbers represent is how many representatives should be assigned to each of these regions. However, you can't assign a decimal of a representative to a region because representatives only come in whole numbers. And so what we do is we assign each region the lower quota, which basically means we ignore the decimal part and we just assign the lowest whole number that's closest to that decimal. So for the capital region, the lower quota would be 55. The central region would be 39. The northern region would be 17. The Zeeland region would be 25. And the southern region would be 36. And then we look at how many representatives that has assigned. So we add up all of these numbers, and when we add them up, we get 172 representatives. But we have 175 representatives to assign. And so this means that we have 3 extra representatives that we need to assign. And the way we do it is based on which regions have the largest decimal. So because the central region has the largest decimal because it's 0.9, that means that we're going to add 1 extra representative to the central region. So the central region will get 40. Then we say the capital region is the next largest decimal. And so we're going to add an extra representative to that region, which is 56. And then the northern region has the next largest decimal, and so we'll add an extra representative there. And that takes care of our 3 extra representatives because we had apportioned 172 of them, but we had 175 spots available. And so we add those extra 3 representatives to the regions with the largest decimal. And then the other 2 regions just keep their lower quota. And so this, if you add this number up, this adds to the total number of representatives that are possible. And so this is what our final apportionment would be. And we would basically just say that the capital region has 56, the central region has 40, the northern region has 18, and the Zeeland region has 25, and the southern region has 36. So technically, I guess that last column isn't really necessary, but that's the way that Hamilton's method of apportionment works. So why don't you try this example on your own? In this example, let's say that there's a business that has 4 different offices in different locations, and they've purchased 10 new copy machines, and they're trying to decide what is the fair way to distribute these 10 new copy machines between their different offices. And the way they're going to make this decision is based on the number of employees at each office. And I just realized there's actually a typo here. This should say employees, not customers. So based on the number of employees that work at each office, use Hamilton's method to distribute these 10 new copy machines to the offices. So pause this video and then restart it to see how I would solve this problem. Okay, so the first thing we want to do is we want to look at how many employees are there total. And so we'll add up 15 plus 20 plus 18 plus 5. And when we do that, we get 58 employees total. Then I'm going to take those 58 employees and I'm going to divide them into a group of 10 because that will tell us the amount of employees that should go to each copy machine. So in this case, that's 5.8. And then I'm going to divide each one of the office employee numbers by this 5.8 to see how many copy machines should go to each office. So I'll do 15 divided by 5.8. That gives me 2.5862. Then I'll do 20 divided by 5.8. That gives me 3.4482. And then I'll do 18 divided by 5.8. That gives me 3.1034. And then I'll do 5 divided by 5.8, which means that I get 0.8620. And so when I look at these numbers, basically what this is telling me is how many copy machines should go to each office. But obviously you can't send 2.5 copy machines to an office, so we're going to round all of the decimals down which gives us the lower quota of 2, 3, 3, and 0. And so that means each of the offices will receive at least this many copy machines, but they may receive more depending on what their decimals are. So once we found the lower quotas, we're going to add them up to see how many copy machines are already distributed. So 2 plus 3 plus 3 is 8, which means that I still have 2 more copy machines left to distribute because this lower quota distributed 8 of them, but I have 10 copy machines to distribute. And so I'm going to distribute those based on what the largest decimal is. And so because this decimal is the largest one, I'm going to change that to be 1 copy machine. And because this decimal is the next largest one, I'm going to increase the lower quota of 2 up to 3. And so that means that Office A will have 3 copy machines, Office D will have 1, and then B and C will stay the same as the lower quota. And if you add up those numbers, you can see that we have distributed all 10 new copy machines. And so those numbers would be the final apportionment. So that's how Hamilton's method works, and you'll be practicing this on your assignment. If you have any questions, let me know.